Well, once again, we're going to measure these 9 quantities, but with decimal units this week. So we know the 9 quantities. Surely we have our favorites and our least favorites by now. And we know that when we measure those quantities, we might get whole numbers, 144 square inches. We might get fractions, 1/9 of a square yard. But we might get decimals, like 370 thousandths kilograms or 37 hundredths kilograms. $1.44 of a second dollar, or $1.44, or 245 thousandths of a meter, 24 5/10 of a centimeter. This week we'll be talking about the ones that yield decimal measurements. We'll still add and subtract the same way. We'll have parts, but our parts will be decimal parts. And we'll still multiply and divide, but our groups or our multiples will be decimal measures. So we'll have multiples of decimal measures. Remember, in money, we had $1.44. You might say I have $1, 4/10 of a dollar, and 4/100 of a dollar, minted before 2010. And we call those tenths of a dollar dimes, if we'd like, and those hundredths of a dollar pennies. Just like we call eighths of a gallon pints, rather than eighths of a gallon sometimes. Sometimes we have names for them, sometimes we don't. And then let's see, I have 4/10 and 7/100 of a dollar in pennies minted since 2010. How much do I have in all? Well, let's see, I'll add the dollars, I'll add the tenths of a dollar, and then I'll add the hundredths of a dollar. So I have only $1. 4/10 and 4/10 is 8/10, and 4/100 and 7/100 is 11/100. Do you see my 11/100? Do you see my 1/100th in the hundredths place? And do you see I have 1 in the tenths place? But I know that there's 10 hundredths and 1/10, and so I actually do have 11/100 there. And when I add that together, I get $1. Let's see, 8/10 and 1/10 is 9/10 or 90 cents, and 1/100 or 1 penny is 1 cent. So 1 91/100 of another dollar in all. Adding unit by unit, just like I did with whole numbers. And then remember my 4 shelves. If each shelf is 245 thousandths of a meter tall, and I want to make it, let's see, I can either have 4 shelves, each of that height, or I can think of a single shelf and make it 4 times as tall. Either way, I'm multiplying by 4. So I'll have 2/10 of a meter, 4/100 of a meter, and 5/1000 of a meter, all being multiplied by 4. Well, 2/10 times 4 is 8/10. 4/100 times 4 is 16/100. Do you see my 16/100? 6 of them in the hundredths place, and 10 of them represented with that 1 in the tenths place, because there's 10 hundredths in every 1/10. And then 5/1000 times 4 is 20 thousandths. Every 10 thousandth is 100th. 20 of them is 2 groups. So that's 2 groups of 10 thousandths, which means 2 10/100ths. And now, when I add my 8/10 and the 1/10 from 16/100, I get 9/10. And when I add the 6/100 from the 16/100 and the 2/100 from the 20,000ths, I get 8/100. 9/10 and 8/100, 98/100ths of a meter. Yep. So I am multiplying unit by unit, starting with the largest unit. I want you guys to practice that on this number right here before you start creating your own. All right, let's meet a few more decimal units, because we'd like to meet all the different kinds of units before the end of the term. Luckily, you'll have 5 years, 6 years if you count kindergarten, to teach your students, but we only have 10 weeks, so we're going to meet a few more today. Let's see, units of time in seconds. So when we divide a second into 10 pieces, we call it 1/10. We write 1/10 as a fraction or 0.1 as a decimal. Each read 1/10. When we divide a second into 100 pieces, we call each interval 1/100th, and we write 1/100 or 0.01. Each of those read 1/100th. Let's see. The horse race pictured took 1 minute, 11 seconds, and part of a 12th second. And it was a dead heat. Look, can you see? The first two people have the first two horses or jockeys have the same score. 1 minute, 11 seconds, and 42 hundredths of a 12th second. Yep. And we can write that as 4/10, written as decimal 4, and 200ths written as 0.02. Or we can write 0.42, putting them together, the 4/10 and the 200ths. So we often use, go all the way to hundredths or sometimes even thousandths of a second in athletic races, horse races, and swimming, say in the Olympics. In pairs, here's a couple activities. In pairs, you could give a student a piece of bubble gum, have her pop the gum into her mouth, and chew it until she's able to blow a bubble. Have the second person time his partner to see how long it takes to blow that bubble. Collect the times in the whole class. Give them a stopwatch. They'll be able to measure to hundredths of a second. In pairs, you could ask one person to walk down the hall as fast as he can without breaking into a run. Have the other person measure it. Same thing. Once you have all those times, you can, add them, combine them, as though it's a relay. You can compare them to see who's fastest. You could find the difference between them. You could pretend one person was going to do it over and over to get multiples. You could ask how many they could do in a minute or in 2 minutes or something. You could add, subtract, multiply, and divide and order them. You could also put all of them on a line plot. Everybody's time on a line plot. That'd be fun. All right. You might use a horizontal number line because it's time. Time is passing. You might use a line plot. There we go. Narrative or number sentences to model time. All the way to the hundredths of a second. All right. Units of volume. Liters. Oh my goodness. I forgot to add the picture here. Imagine a picture with a liter container, and on the side of that liter container, are 10 separate lines, or 100 or 1,000 separate lines. I'm so sorry. Chalk this up to, we're not looking for perfection. We're just having a little fun learning. If you divide the liter equally into 10 pieces, you call it 1/10. If you divide it into 100 pieces, you call it 1/100th. And look, we sometimes even do split into 1,000th pieces and call it 1,000th. Write 1/1,000 or 0.001 for 1,000th. Let's see. Provide a container of liquid for each group of 4 students. Have 2 students pour the liquid into a graduated liter container to determine how much liquid there is. The reason you have 2 people is one has to pour and one has to hold. If it's water, you might make a mess. And then have a third person draw a picture of the liter container or a number line, vertical or horizontal, to represent the amount measured. I think you want vertical for volume. And then have a 4th student write a sentence telling how much liquid was measured. So you have a picture and a sentence. Probably that sentence will have a number in it. 2 people pouring to make sure we don't make a mess. Have every pair of students measure the liquid provided to them and mark it on a Post-it note. Have them all post their notes on a board, organizing them as they go. You could create a line plot, do all kinds of statistics on it. How fun would that be? All right. Vertical number lines, line plot if you're doing several of them, vertical number line for a volume, narrative sentences, number sentences, as always, great models for volume. All right. Let's talk about the 9 quantities. We've measured weights of strawberries. We've measured linear distance of my shelves. We've introduced volume both as fractions and as decimals. We did area of the calendar pages. We haven't met temperature yet. We met time, hundredths of a second, halves and fourths of an hour. We met angles of a circle. We've met money, and individual objects or occurrences. We count those all the time. So it looks like we're down to just one quantity of the 9 that we haven't really met, which is temperature. One of the reasons is temperature is often used to introduce negative numbers for very cold temperatures, and we're not going to do negatives in our course. Can't do everything in 10 weeks. All right. And you're going to be writing word problems. Yep. Operations on numbers, but not just whole numbers. You've already done fractions. This week you'll do decimals. So let's have fun with it. Can't wait to see what you guys come up with.